everyone, so this is your brief summary of integration, and the key fact here is that differentiation and integration are inverse procedures of each other. So if you take a function and you integrate it and then you differentiate it, you get back to where you started. If you integrate the derivative, you get back to the function plus a constant, because the last thing we did there was integrate. But the key thing to remember is derivative and integral cancel each other out. Okay, and that's a good way of checking to see if you have the correct antiderivative. So if, for example, you're integrating 5x squared, for example, dx, and you raise the power by 1 and divide by the new power plus your constant c, if you want to check that, differentiate the function. Okay, so when you differentiate 5x cubed divided by 3, you end up with 5x squared, and the derivative of the constant is 0. All right? Okay, there are two here that you might like to memorize. I'll give you a hint for getting there. So in your log tables, you are given the fact, this is page 26 of your log tables where you have all your integral formulas. The cos of x dx is the sine of x. But then if you're asked for the cos of 2x, the thing with integration is that we don't have any product rule, quotient rule, or chain rule. So you oftentimes have to do a bit of algebra to get the function to look like one of the functions on page 26. But there's no algebra you can do with cos of 2x to make it look more like a function on page 26. So you kind of combine two rules. There's another rule there that says e to the ax dx is 1 over a e to the ax. And I feel that is a bit of a hint for being able to integrate, let's say, the cos of ax or the cos of 2x, because you integrate cos as usual, okay, to get sine, evaluate it at 2x, and you divide by the derivative of 2x, which is 2. So that's kind of like what's happening with the e to the ax function. If all else fails, I would memorize this and this. So you know the antiderivative of sine is minus cos from the log tables. If you have a number in front of x, it's minus cos ax divided by that number. And don't forget your constant of integration, c, if you have no limits of integration. So a few of the things you can do with integration, you can find the area bounded between two curves. To find the area, you integrate the top function minus the bottom function. That's what you have to remember. And you're always thinking vertically here. So top is green and bottom is blue. You're integrating f of x minus g of x. Now, you might be given the points of intersection, you may not. They will be your bounds of integration. So the steps are, first you might need to find the points of intersection by solving the two functions equal to each other, as you always would. That gives you the x values for the points of intersection. And then we integrate the top minus the bottom between the points of intersection. And as with any question, area, volume, length, they should always be a positive number. So if you get a negative number, that's a good reason to go back and check your calculations. One little one here that can throw a few students, the integral of 5 over e to the x. There's an instance where we can integrate this function. We don't have a quotient rule for integration, so a little bit of algebra brings us to, or the rules of indices brings us to 5 e to the minus x. Leave the 5 as it is, and when you integrate e to the minus x, you get 1 over minus 1 times e to the minus x. So we're using the rule e to the ax. The antiderivative of e to the ax is 1 over a e to the ax. But there's kind of a hidden a there. You know, the number being multiplied by x is minus 1, and that's your a. Average value of a function over an interval is this quantity here, and that you do need to know. We've talked about position, velocity, and acceleration in the previous video. And the trapezoidal rule there from page 12 of your log tables, that can be used to approximate the area under a curve. That's why I included here in the integration section. And you have the rule in your log tables. Here it is. H is the length of each little interval there, the length of each kind of wedge. And then y1 is the value at the left end point, y2 is yn is the value at the right end point. So they're the ones that exist on their own at the beginning, and then you've twice all the values in between. Okay, that is the heights of the functions in the interior there. H is the width of each interval. And then just in integrating, we don't have any product, quotient, or chain rule. We often need algebra, so the likes of this, you would divide each term by x first to reach a point where you can actually integrate each one of those. All right.